to cloud. Right. I would like to thank Mr. David for his introductions, and want also at the same time to welcome those that have managed to log into tonight's discussion. I don't want really to call it a lecture, but it's a discussion where I will be doing most of the talking. Right. The topic that I picked is basically something that I'm trying to convince people on the need for quality management in ultrasound imaging. Using my background as someone who is on a day in, day out basis practicing a lot of quality management, I thought it would be nice to have an overview on how ultrasound imaging can benefit from the current trend in managing quality in the medical field, especially in hospitals and clinics. So I'm sure everybody's seeing my screen. I'm not sure. Let me try to just something quickly. Right. So my name is Remy Makufa, and we are going to talk of quality in ultrasound. The first issue is that we want really to define what quality is, and why worry about quality, and who should care about quality. And remember, all this is happening in the perspective of ultrasound imaging. And then we also would look at, in terms of the quality, who determines what quality? Is it the buyer? Is it the seller? Is it the recipient? Is it the giver of the quality? And then we have a quick look into the process management and highlight a little bit of ISO 9001:2015 as something that most of us can adopt in terms of starting the movement in configuring quality systems for our clinics. And then, of course, we'll then look at how to tame quality issues in ultrasound imaging, looking at what can go wrong. And then, if we can find what can go wrong, how can we fix it to achieve quality? And then, of course, lastly, before we go to discussions, will be what is the big advantage in implementing quality in ultrasound imaging?
Mr. Makufa, may you put on full screen your presentation?
Okay, all right, let me try that. Just a second. Just a second. Right, are you having it in full screen?
Yes, thank you.
Okay.
Yeah, looking nice.
It's better now, thank you. I think I was looking at the other screen because I think I had an off shared screen also. So I think I kind of mixed the two, sorry for that. Right, so we've gone over that one in terms of what we are going to talk about today, which is an overview. And then we'll basically dip into it. And this is trying to define what quality is really about. And what I've done is just picked from literature about 4 definitions or 4 statements that tend to talk about quality. The first one is from Edward Deming, who is basically the guru in quality management, where he says quality is everyone's responsibility. And if you look at the right side of that screen, I've put a few words in red. So what you're picking from Mr. Deming is that quality is everyone's responsibility. It's not an individual's responsibility. And then we have from the CEO of General Motors, where they say, my definition of innovative is providing value to the customer. And then I picked, again, value to the customer. Then we go to Steve Jobs, the late Apple giant. He said, be a yardstick of quality. Some people are not used to an environment where excellence is expected. And I picked the word excellence. All this is going towards trying to define what really quality is about. And then the last one is the transformation to world-class quality is not possible without committed, visionary, hands-on leadership. And I picked committed, visionary, and hands-on leadership. Right. The UK runs what is called the Institute of Medicine, which is sort of very central in terms of defining a lot of policies in how medicine run in the UK. And a lot of countries and other institutions tend to follow what the Institute of Medicine leads, right? They define quality as, or quality in terms of what it would then achieve in terms of mistakes in diagnosis. So the failure of a planned action to be completed as intended, or the use of a wrong plan achieved. Right. And we are looking at about a quite huge number of errors that happen in the American situation. We have about 44,000 to 98,000 Americans who die each year because of medical errors. And we are saying, is it anything to do with quality that we have so many medical errors taking place? Right. And of course, that is in terms of diagnostic errors, but you can also talk in terms of the actual equipment that you use, where you are talking of defects in the structure or function of equipment, right? Where the equipment might end up giving you errors. But the one that I like most, which I put in yellow, is by Wu and colleagues, where they talk of errors in terms of quality as a commission or omission that has got negative consequences for the patient. And the take-home word is patient, right? Because central to whatever we do in medicine, we want to give the best to the patient and probably do no harm, right? But why this Wu definition makes a lot of excitement to me is that it goes on to say, when that omission or commission is done, would anybody else who has got a more skilled or knowledgeable understanding of imaging, would they have made the same mistake or made the same judgment, right? So central to quality is that we want to reduce these errors in the medical environment. We want to reduce these errors in ultrasound. And people might actually ask themselves to say, do we actually have a lot of errors in ultrasound? Or probably we find them in CT, and MRI, and other modalities of medical imaging. But I will argue in a very short while that we actually have a lot of errors that happen in medical ultrasound, right? Where are these errors coming from? It's a big issue. If we have errors, yes, they might be there, but where are they emanating from? Right? I have a good slide here from RSNA, from their magazine, flagship magazine, Radiographics. This is basically from Mr. Reason, where it shows how errors filter through and ending up being an error in diagnosis for a patient. So you start off with the hazard, which goes through the culture, training, and clinical support of an environment, right? And there are issues that can happen in all that process, whereby you can then end up with either misjudgment or erroneous diagnosis, or sometimes you can also end up with damaging equipment in ultrasound, like probes or the screens or anything that might fall in that way. And of course, if you see the halls of defense, what we are simply saying is that in all that process, we have opportunities to be able to avoid a hazard turning into a diagnostic error, right? So the quality shapes itself by us having opportunities to be able to identify and stop by blocking the holes in our systems. So we want to block holes in the culture of the institutions or the way we do things. We want to block holes by make sure that people are trained and that there is support, which could be infrastructure support or managerial support, which goes also to leadership. Right, but I think when you talk of medical ultrasound, the central person basically is the ultrasound sonographer. I don't know if people can see that screen. It might look a little bit small, but anyway, there is a requirement for the radiographer, which is educational preparedness and clinical competence. It's like that if you go back to my last screen, you find that when you equip the sonographer with good education, which is training, they can then achieve good clinical competence. And that becomes a prerequisite for good professional practice, which then will translate to good quality. Now, if you look at the impact, because sometimes you might talk of errors and everything, but I think it's important to look at what impact that might have in the system, right? So the impact of diagnostic error in the US, I mean, I want to quote the US because that's where you have a lot of information available. I tried to do a Google search for errors in SADC region and other African regions, but I couldn't find much. So I said, okay, fine. But we then understand from that text that there are definitely errors in our systems, right? So the impact, we have at least 5% of adults that seek outpatient care experience diagnostic errors. And that contributes to 10% of deaths annually and up to 17% of adverse hospital events. Now, on top of that, there is also a monetary issue with medical errors, right? So the question that all of us would then want to ask ourselves is, do we have an idea what that impact is in our own environments? And the only way that we can have an idea of how much monetary losses we have, how much adverse events we have in the process of doing ultrasound imaging, then that can then be put out in terms of how much we care or how much we achieve or carry on quality in our clinics, right? So my first question was that, is there really a big issue with misdiagnosis or errors in medical ultrasound? We all know that there are errors in radiotherapy, there are errors in CT, there are errors in MRI, there have been consequences. But what I did is I actually picked up a very nice article from Contemporary Obstetrics and Gynecology publication, that was of July 2019, where they talk of the legality of ultrasound errors. So they picked on how important is an ultrasound report. Because what normally happens if you're in a clinic is that you tend to get the ultrasonographer. In some cases, it might not be an ultrasonographer because of the technology. It could be the medical doctor himself that does the scan, or it could be an emergency person in paramedics, whatever it is. But what happens is that there are errors that will actually happen, right? The first case that I picked was that there was a settlement for $1.9 million, where a baby was born with midline fascial defect and other complications. And the radiologist, right, during the litigation process, actually admitted that they had not reviewed the images from the studies or the sonographer's handwritten report about the findings. So there was a finding which was pointing towards those problems with the baby, with the fetus. But the radiologist, for some reason, chose not to go by the detail of the report. And eventually, when the baby was born, because then they said everything would be normal. When the baby was born, there was those complications, and it went to court. And that's quite a lot of money, $1.9 million. And there have been a lot of other cases whereby, like for example, the third case, where there were a lot of unnecessary procedures being requested by a group of hospitals, and the Department of Justice ended up fining the group $10 million for those unnecessary procedures. And what would have happened is that if the system was controlled, where there would have been quality, there wouldn't have been a result of unnecessary procedures, and they wouldn't have come up with a 10 million litigation process. The same thing with the first case, whereby there was a settlement of 1.9 million, whereby if there was a sure communication between the sonographer and the physician, then there wouldn't have been a result of misreporting, right? So my argument is that we definitely have issues of errors, issues of quality in medical ultrasound imaging. Right. Now, the most important issue is I mean, we know that we have got equipment and procedures in medical imaging, right? And most of people that do practice, they probably know what they need to do. But the most important aspect is the process quality issues, which is most important for any clinic or any medical facility, no matter how big or small it is. And I'll quickly go through ISO 9001 in 2015, which is the most current offering for quality management of processes, right? And what this does is that it looks at organizing processes in clinics or medical environments. It looks at improving the efficiency of processes, and it looks at continual improvement, right? So what is happening is you look at your processes and say, okay, fine, this is what you do from A, B to Z, and that makes your process the way you do things. And then you say, okay, fine, how do we properly organize these processes? And then how then do we improve to make them work optimally? And when issues come up, for example, when errors come up, how do you then come up with a process of improving those issues so that tomorrow you don't have the same problems coming up? Right. So before you go to that one, sorry, can I go back one stage? Now, if you look at the whole field of ultrasound, which is a subfield of medical imaging, the first issue that happens with quality is that you need to, for example, to plan in terms of coming up with a facility. And when you have a facility, you're going to look at the internal resources, which might be staffing. Do you have the right people to do the scans? Do you have the right people to do the reporting and the interpretation? Do you have the right people to type out reports or process them? Do you have the right IT infrastructure if you're doing things online, for example? Right. So the first issue basically is you really want to plan out in terms of buying the right equipment, right? And the first stage in trying to buy out the right type of equipment is to look at your vendor to say, do they also have processes, right? And there are several ways of looking at vendors. One is you could go on the internet and fish out, for example, if you look at ultrasound, which vendors are ISO certified or they have a good process in place, right? So what people need to check is there's ISO certification and there's ISO compliance. ISO compliance is simply saying our processes, they agree or they tally well with the requirements of a particular standard, but we have not gone through a process of registration, right? And that is important because it's the initial stage. Because if you miss out the initial stage, it means to be very difficult along the way to come up with a quality program that avoids errors and further on patient harm, litigation, and also even stress and other issues to imaging staff. Right, that one I've talked about that. I can leave that. Right. So I just wanted to show you quickly how then, if you're out there trying to start off your process, right? How do you check who is certified, who is not? And what I came up with is a very nice document from Stemma Imaging. It's a German company. What you would have is normally is a certificate which shows you the name of the company and I don't know if people can see I'm trying to put, okay, you can see that screen over there, right? So what you have is you have a certificate and it says this is confirming that that company is certified 9001 2015, and who certified, this is the company that certified, this is, and then you have the scope at the bottom of what issue, what scope or what areas of the company are certified. And then that gives you a good head-on in terms of whether you are working with a good company or not, right? So that's when one way you see whether you actually have a certified company or not. The other option is you could go on a website, for example. I mean, I am from Life Healthcare, but I could probably use it as an example. Sorry, that will not work, right? But no matter what happens, is on the website, you would find, let me try again. You would find that there is a statement that is normally put on the website or on the marketing information, a statement of, sorry, this one is really refusing to come up. Let me just get out of it. Okay, there we are. This is Life Healthcare. I'm just using it to highlight the fact that if you look at that aspect there where it says Life Healthcare was certified for ISO 9001 2008 and is working towards the current 2015 standard, then you are sure as a starting point. But then you could go in and request to say, can I have the certificate of quality for that company? So this could be a company that sells ultrasound equipment, or this could be a company that sells maybe is additional infrastructure for your facility. You could then, after seeing that they're certified, you have the right to ask for the additional information. So as much as the patient would also have a right to ask for your own standards, if you have a certification or you have compliance, whatever it is. Right. Now, let me quickly dip into the basics of the ISO 9001 2015. Right. I'll quickly go through this. I think most of us have seen this before. This is the basics of a quality management system, where you have you could start at any point you want, but the first one is a process approach, where you say there are a lot of processes in how we do things. Then there is the management issue. Then you have involvement of employees, the leadership, you have users, and then you have partnership between decision making and user orientation. And then the most important in every environment is the continual improvement, right? To say, once you start a quality process, it doesn't stop. It's a continuous process, right? Now, quickly, we'll look at the way ISO 9001 is structured. The document, if you pick it up, it has got different sections, 10 of them, which is the current configuration. And the important, of course, is if you start off with section 5, where you have leadership, and then you have planning, which we are talking about in terms of the initial stage of saying what you need to do to start planning your quality, right? And then we have support, then we have operation, performance evaluation, and improvement, right? This document is widely available for free online for download. So those who might be interested to have a look, who haven't seen it, can actually pop in and have a download there. Right. So of interest will be 9 and 10, but basically 10 becomes very much interesting in terms of individual clinics. Right. So 10 basically is based on the PDCA cycle, right? Plan, do, check, and act. And it becomes a continuous process for every activity that is done in a clinical environment. Right. Now, let's come home a little bit, because I've been giving a general overview of quality, basing it on a standard, which is an international standard, ISO 9001 2015, 2015 being the most current offering from the process standard body. Right. Now, in ultrasound, one of the things that we need to check is that the transducer, which is working properly, and that we don't have artifacts, and that we guard against the physical limitations of ultrasound. And I think we are quite aware of the physical limitations, where you have the presence of multiple echo points when you go through a tissue. And then, of course, we might have velocity errors. I'm sure we're aware that in most cases, the velocity that we are having is actually an average or an assumed velocity, because different tissues have different velocities. And then, of course, we have attenuation errors. Now, we need to develop a comprehensive process to do 3 main things, right? And these methods must be very robust, right? In the first one is to identify diagnostic errors. Because if you don't identify the error, most likely you won't be able to react to it. So you will never be able to intervene or come up with a solution to that diagnostic error, right? The second is to discover contributing factors and biases. What is it that is causing error or affecting the quality that you want to achieve? And of course, the last one is once we are happy with those two, we then say, okay, fine, let's develop interventions, right? If I go in a little bit, just quickly into different methods of identifying diagnostic errors, and this again is part of the quality setup that needs to be done in clinics. You can have non-random peer review. Peer review is whereby you basically ask other users to routinely look at your work and see if they come up with the same result, right? Very useful. And then of course you could set up tumor boards and multidisciplinary conferences where maybe once in a while, once monthly, maybe bi-monthly or something like that, you convene and look at different cases where there were errors and try to formulate a plan as to how those errors could have been avoided, or if other people had the same errors elsewhere in other clinics, how they actually resolved and made a plan to avoid those errors coming up in their clinics. And then, of course, you could also use reinterpretation of outside studies, where you pick studies from other users, without really being part of a multidisciplinary setup, and to try to see if you can come up with the same result. And then, of course, you can also use patients and referring physicians. One of the most interesting things with medicine today is that most patients are actually highly involved in their own care, right? To such an extent that they may actually help to pick a discrepancy in a report back to either the sonographer or to the reporting physician. But most institutions do not actually take advantage of that development in terms of knowledge to say the patient and the referring physicians can be part of the quality process to avoid errors, right? So the take home here that I have, which is more or less learning point, is that the referring physicians are likely to notify a radiologist of a diagnostic error if they know the process by which the case should be handled, and that there is a non-punitive culture, right? What it means is that the reporting system is developed to enhance onward and continuous learning to avoid errors in future. Right, so we have reinterpretation of outside studies, we have involvement of patients and referring physicians, and then of course we also have analysis of errors, which I tend to believe that a lot of us do, but it also depends on what depth and what constructive way we are doing it, right? So basically what you are doing is you identify errors and then you analyze in terms of the contributing factors. I will use another slide from RSNA, where it's basically using the RCA methodology, that is a fishbone or Ishikawa diagram. And what you do is you look at different aspects. Let me try to zoom that, right? So there are basically different aspects where you have. So what you're looking at the end of the day is the diagnostic error. And you are saying what is causing this in terms of the contributing factors. So you have equipment, which is your ultrasound scanners and everything else. And I think also in terms of that, you could take your ergonomics in as part of as the equipment. And then you have the environment, the lighting, the noise levels, the cleanliness of the workplace, and how friendly it is. And then you have the people factors, right? We have knowledge, we have for knowledge for the sonographer, for the radiology, and also have patient factors, and you also have policies and procedures. Right. I mean, day in, day out, we are doing procedures, but we probably might leave this aspect of writing down what we do, which is the issue of documentation, right? So there's issue of policies and procedures, which makes it possible for whatever we do to be repeatable. And in that, we have things like workload. Do we have enough work? Do you have enough staffing? And that goes into planning, and that affects quality in a big way. And then you have processes. And of course, in most cases, if you look at most errors that have happened and end up in litigation, it's because people tend to ignore the underlying pathology and simply jump to write up a diagnosis and end up dipping yourselves in diagnostic errors. Do I hear somebody saying something? Okay, I think I can continue. Right. And then the other issue is also the issue of educational intervention. It could be done at a local level, senior, more knowledgeable people training the other ones, or you could plan as part of continual development of your staff to go to conferences, to do short courses, and that comes in a big way as well. So that's educational interventions. Right. Now, this is what we normally have in a setup. We have the main quality player in an ultrasound clinic being the sonographer, right? But besides the sonographer, you might also have nurses, depending on the setup of the clinic, or paramedics. Look at MRI, you might find that in their ambulances, they might actually have some portable ultrasound equipment. And you also have medical doctors who might also do the scanning without actually being certified to do that, right? And then the sonographer being the main player, they are supported by engineering and medical physics in terms of what they can do with equipment, in terms of what measurements can be done, what is the QA or QC that can be carried out. So that becomes a team that wants to achieve the goal of having proper equipment operation and detecting gradual changes in the equipment, because the problem with equipment is that they wear out gradually. And by the time it causes a problem, it normally ends up with a diagnostic error, right? And also, of course, you want to minimize downtime in terms of your business. Sorry, this is running. And of course, reduce the number of repeated scans. So basically, we are saying, if we go back a little bit, we have issues with one, purchasing, which is the starting of planning, identifying the correct vendor. And then once we get the correct vendor, we know we have the correct equipment and we have the correct internal resources and internal support. If it's a big institution where you have HR and other things, and once we do that, then we are saying, okay, fine. When the equipment comes, we then get a handover from the supplying company, the company that we have certified that they have processes that are in place. So it could be a generic process, which is to me the most important to start off with, or it could be an industry process where they are assured of their equipment quality. So once that is done, we then have a baseline of our equipment, how it operates in terms of the specifications. Once you have a baseline, then we can now start talking of, we can talk of an expected quality from our procedures. And then we talk of QA, which is quality assurance, and then talk of QC, is quality control, which is the next slide. So we have QA, QC, and inspection. So you might find that some people are already doing that, doing some form of QA or some form of QC or some form of inspection, right? But what normally is not available in most setups is that this is not managed in terms of having a definite or a premeditated or planned quality management system, right? So QA, which is quality assurance, is basically to say, I want my equipment to continue operating in future as by my initial receiving of the equipment from the manufacturer, which is at handover, right? So you commission your equipment and then you want it to work throughout with those specifications. QC is something that is done on every point of decision making, where you want to come back and check to say, is this decision okay or not? Is this calculation okay or not? Then you go back to your process and say, okay, I think this point is not correct, therefore you immediately correct it. Then of course, inspection is where you basically like do a quick look at your equipment to see whether there's anything that is telling in terms of where, for example, it could be cables or the transducer cracking or something like that. So the process will involve three things, basically: measuring, examining, and testing. Right. I think this is more or less a repeat of that. Let me go in here. Right. Now, I think we now go into the deep and say, fine, as in ultrasound imaging, right? We already have, no matter what you buy, there is a generic or a functional aspect or a functional architecture of all the equipment that you require, right? And that diagram basically gives you an idea of what every equipment looks like. It could be portable, it could be one that is on a cart. So you would have an electronics, you have your probe, you have a workstation, which is computers, you've got front end issues, you have cables, and anytime can go wrong with those things, right? And what you want to guard against is being ambushed or surprised when you find that the cable is not working, or there's something wrong with my computer workstation, or probably sometimes you might find that because this is mobile, you could have even the wheels coming off or something happened to them. And to stop that going, you then need to put up a process where you check on a defined frequency what aspects you think are more important to your function, whether it's mechanical, electrical, or whether it's the software. Sometimes the software might have bugs. Somebody can come and use a memory stick and transfer some viruses onto your system. You want to check that the software is intact. How are you going to do that, and how often are you going to do that? You're going to have issues of your data on the ultrasound workstation. Is it going to a PAC system? Is it going to a local hard drive? How do you assure that data is integral over time? You have the monitors. The quality of the monitor also determines how quickly you can see your images and have a good interpretation. How do you do that, and how often? That then forms part and parcel of your quality assurance process, which is part of your quality management system. Right. So just an add-on to the acquisition decision-making process, that you need to be sure what exactly you are getting in terms of your requirements. And that breaks down your system into basically two, portable and cart-based. If you realize what is happening at the moment, that there's quite a huge surge of portable ultrasound systems, which are microprocessor based, and some of them you can come in onto a cell phone type of device. That's portable. So you need to be sure again what can be tested on those kind of devices. The economics, because we are saying that two issues here. We have the equipment, and then we have the people. Like the equipment, we can look at the changes, the design and everything, but what is it for the user? We need to also to protect the user, and that is what we then come up is economics for the user. And you need to make a decision to say, what do you need to avoid, for example, users straining their eyes or having musculoskeletal problems in future because of the arm movements. And a lot of equipment is coming with quite a lot of add-ons. For example, they actually come up with motion analysis and eye tracking, which then feeds back into how you work and improve, so that you don't have a lot of medical problems as the user. And again, that's economics, which goes in terms of the initial quality process of buying. Now, this is what I've just touched here and there as I was going. What can go wrong that will impact on your quality, right? One of the biggest things that happens with ultrasound equipment is frayed cords. And then, of course, you have people, sometimes they knock transducers or drop them. So you have cracked transducer casings, which are an electrical hazard to the patient and the operator. And one of the things that it needs to be in your quality management system or the quality assurance is cleanliness of your equipment. Things like dust, they really cause a lot of havoc. But if you don't have a definite time and plan to say every morning somebody has to clean the equipment or to dust the equipment, then over time the dust accumulates and it ends up actually affecting how the outcome of your measurements. Right now, when you know that there is an issue with sterility, then you could, as in the initial plan, buy sterile covers for your equipment so that you could cover the probe and the entire machine with the sterile covers that you remove and keep on the side, right? This is sort of hammering it in again, right? Why are we doing quality? It's putting it back into perspective. We want to assure patient safety, or we want to give the best to the customer. We want to protect ourselves and the patient from misdiagnosis. We want to run away from litigation, right? And why it's important to come up with a QA system is because if you look at 90% of the faults that are detected are normally by physical inspection and easy tests that can be done by most sonographers on a daily basis without specialized methods of measurement. We will look at some aspects that you could do in terms of coming up with your QA system. Right. So the principal concerns, as you said, in terms of the frayed cords. So we could have, for example, failure of the actual crystal elements, but you should be able to check whether they are failing or not. Have a method for that. You could have issues, for example, with keyboards or trackballs that they're not working properly, and they would actually give you problems in terms of probably how you do a measurement when the trackball sticks and or it doesn't click in to pick up a point. Right. So now we are saying you could set up your QA system in a way that it fits within your budget. So you could find basic measurements which do not need specialized equipment, right? Like, for example, just firing the ultrasound into air and looking at the reverberations measurement, where you're looking at different points. As long as they are consistent, then you are fine. But you could also use phantoms, right? Phantoms are good because then they give you a determined measurement environment where, for example, if you're going to measure distances, you know exactly what the distance are because it's fixed. Or if you're going to measure elasticity, you then know because the material that is in the phantom is known. But the things that you probably would need to measure are not too many to have a good working equipment, right? The next slide will simply try to give you an idea of what things you probably need to measure, right? So what this table basically gives you is the item to be measured and the detail. What are you actually coming up with, and how important or is it, or what causes it, in the same way. So in most cases, you want to know the axial resolution, the lateral resolution, and also you want to know the beam thickness, or you want to look at registration or the dead zone, and you also want to look at sensitivity, right? These are the kind of the basic things that you would do in your QA system, right? And remember, if you're gonna have to do that, then that also must be in your baseline when you started off with your QA or acquisition for the new equipment, right? I won't go through the other part there, but for those that might want, I will probably share at the end of the day the slide. Right, this is the A test, which is very basic, but it's very good in terms of measuring uniformity and sensitivity, and also picking transition noise, right? And everybody can actually quickly use that as a QA system. Or what you could do is you could buy a commercial phantom, which does quite a lot of the measurements from uniformity to dead zone assessment. But you are probably looking at a figure of investment around $3,000 US, which I believe in terms of a quality institution, that should not be much. But if the budget is not permitting, then people could then go into fabricating low-cost phantoms using ultrasound characterized gels or materials. Right. Now, if you open up that phantom, basically what it does is it gives you different materials which are known in terms of being characterized. So when you measure, you're simply saying, I want to get the same output every time. That time I'm going to use the ultrasound machine, and anybody can use that and verify, and you also have a record of measurement over time. And because these are different materials, as long as you can be able to get somebody with a decent workshop, they could fabricate something with gels and different materials, and then you use that as your QA phantom instead of actually investing in a commercial one. Although I still argue that a commercial phantom is something that is a requirement and should be actually part of the initial buying process, where you say, I'm going to buy my equipment, and that equipment should include the phantom. I think that is also traditional in most emerging sciences. And there are different phantoms that one could basically go in and buy, and the basic one is the general resolution phantom, which should measure axial and lateral resolution. It measures penetration, which is basically your depth, and of course, it also deals with your geometrical accuracy. And then you also have for Doppler, there are specialized Doppler phantoms. And I mean, these are not really difficult, even in terms of setting up, through a decent workshop, because it's a motor circulating a fluid at a known rate. Then you could and in different direction, then you could actually do a scan, and as long as you get the same result, then you are fine. But you could then actually buy that. Then you also have phantoms for elasticity, which are measuring material rigidity. Now, how quickly, I think we are still on time, I guess, go on a recap. What do you want to do with a quality management system, right? So we want to guarantee quality of our systems through care and preventive maintenance of the machine to ensure accurate performance. Why accurate performance? Because we want to avoid errors, which would lead to misdiagnosis, which would lead to patient satisfaction, which would avoid us going into litigation, or we should improve our working processes, right? There are daily optimal operation of the machines, which can be done by the user, and they're very quick. And the take-home thing is that once you identify problems with your equipment, there must be a process of immediately escalating or reporting the problem for probably immediate repair or recalibration. Now, this is, to me, more or less of a learning point. The absence of quality assurance could undermine the diagnostic quality of ultrasound examination and expose the operator to innumerable risks, including the health of the patient. And remember, also the health of the equipment and the health of the operator. There is quite a lot of information available that people could fish in and use to set up their quality management system. And what I've put there is a few of the organizations and where you can find them. I work quite a lot with the AAPM. They have a report that they've done quite comprehensive, which is a QA guideline. And then you also have the American Institute of Ultrasound in Medicine, and then the British one, or the English Wales one, Institute of Physics and Engineering in Medicine. They have a lot of documents on their website, which are free for download also, which you can use to start up your quality management system. I think with that, I would like to thank you for taking your time to listen in, and congratulate those that did not manage to sleep. I'll take it back to. We still there?
Yes, thank you so much.
Still there? Okay.
I'm here. I wasn't kicked out.
Okay.
Yeah, usually my internet is really horrible. So at this point, I would like to open up for questions. So you can kindly, I think, Mr. Makufa, from your side, you could just, I think, stop the recording. The questions will not be captured.
Okay. I will
Yes,
stop it now.